Let's go through secant 59 split array into consecutive subsequences. For this question, it gives us an integer array. And this integer array, they are sorted in non-decreasing order. It asks whether we are able to split array into consecutive subsequences. And the things that those kind of consecutive subsequences, they need to that is, for example, they need to increase exact one more for than the previous number. For example, we have 2, 3, 4, or 3, 4, 5. Those are increased just by one. And also all subsequences has a length of 3 or more, right? So if 2, 3, that is not a valid subsequence. We need but 3, 4, 5, 6. Those are valid. So it returns true or false. The first example, we can separate this kind of array into 1, 2, 3, and 3, 5, 3, 4, 5. So return true. The second one, it return, we can separate it into 1, 2, 3, 4, 5, and 3, 4, 5. And the third one, let's see, we can possibly we can put this as 1, 2, 3, 4, and fourth, there is 4, 5 left, right? And this one, we are missing 6 or missing 3, right? So this has length only 2. So we are not able to get uh, any subsequences which has length greater than 3. Um, separate all of that into all to satisfy the condition. So for this question, if we have a subsequences, for example, 1, 1, 2, 2, 3, 3, 3, 3, 4, 4, 4, 4, 4, right? Let's see, those kind of numbers, they are non-decreasing. Actually, those kind of array, it is actually separate into segments, right? So the intuitive thing is that we can go through those kind of index and count. For example, the one um, appears twice, right? Count. And then if we finish the segment, so the array is separated into different segments. 2 appears twice, right? And 3, it appears 4 times. And in the 4, they appears 5 times, right? So it's easy that we separate those kind of array into different segments. And for every segment, for example, we iterate 4, right? We have these counts. The count is 5. So these 4 number, they have several choices. The first choice is that it forms as an individual 4, right? And which means that it's the start of subsequences at this 4. And another is that these 4 connect with 3 and 4, right? So means we already have a subsequence which has length 2. And the third choice for this 4 is that we have those kind of subsequences more than length 4, which already satisfy the condition, the length greater than 4, right? So we call this we can use the counts, right? For example, we call dp1 means if we end at 4, how many at this kind of index, for example, this index or this segment, right? At this segment, how many counts which end with 4 and they just have length 1, right? And also dp2, we call which end as 4, right? We have length 2, right? So that means for these 2, they are not valid subsequence yet. For this, we need to at least to append two numbers like 5, 6 for this, right? And for this one, we need to append at least 5, right, to get it valid subsequences. And for this one, it already is the valid subsequences. We call DP3 means which end with those kind of subsequences end with 4, and the length already greater or equal to 3. Right? So for example, 2, 3, 4, the count also count to DP3. And for example, if there is 0, this cannot be negative. But the thing is that for any subsequences which are already greater equal to length 3, we'll put that into DP3. So now we come to number 5, right? So number 5 after number 4. So we know for these subsequences, they haven't been valid, right? They need some kind of numbers, right? So the thing is that first condition is that after 4, right, we need to check what's the next segment, the numbers. For example, there is no 5 for it already goes to 6, right? Then this one, they haven't been satisfied the correct sequence. So of course we'll return false, right? So if we are able to go to ignore the 5, right? So let's say the two conditions. If after 4 they are consecutive 5s, we count how many 5s, right? So first thing is that this one is just one greater than the previous, right? Previous is 4 equals 5, right? Then we need this count. So this count should be greater equal to dp1 plus dp2, right? Otherwise, we don't have enough counts to make those kind of subsequence valid. So the first thing we need for those kind of 5 is that we need append those to get this kind of subsequences, right? So we'll have, for example, this 4 appears, this appears twice, right? 1, 2, 3, 4 appears twice. 3, this appears twice, and this appears once, right? So what we need is we need 1, 5 here, 2, 5 here, right? Because this is appear twice. And for the rest, right? So that means if the count 5 is smaller than 3, well, of course, return false. But if it is greater than 3, so should we use this 5 as a new subsequence, start of a new subsequence, or we should use this 5 to the one will already be valid? Actually, we should try to put the rest as the DP3 as we can, right? So what we want is that we will put this 5 to here, right? So that because if we create a new subsequences, what happens is that this one will still missing, will append more for the new one, right? If that is just DP1, because the DP1, it need more consecutive numbers to satisfy. So we should greedily put that here, right? Put it into the DP3. So if the 5, for example, it is greater than DP1 plus DP2 plus DP3, then the rest of 5 will put as DP1, right? So this is a case when this is consecutive. So if there is no 5s, it goes directly to 6, 6. What we need is we need to see the conditions, right? If it goes to 6, 6 directly, that means for this one, we cannot have DP1 or DP2 because they are they need five, right? We don't have five. In this case, we need to return false directly. And if DP1 and DP2 they are already uh, zero, right? Then what we do is that for this six, we put as a new DP1, right? Because they cannot be consecutive with this DP3 either. So the DP because that means that we start a new segments, right? New subsequences because it already been separate, jump to from 4 to 6. So in the end, we need when we iterate the whole numbers, we want the DP1 equals to 0 and DP2 equals to 0, right? Just return these two conditions. That means we don't have incomplete subsequences. So let's write code for this. So we need a int dp1 equals to 0 and dp2 equals to 0, dp3 equals to 0, right? Let's have n equals nums dot length and have a count, right, equals to 0. And we need a pre because after we count this kind of segment, right? For example, this is 5, 5, 5, 5, 5, 5. We need to check in the previous segment what the number it is. If it is 4, right? Then we have logic to have this count put into DP1, DP2 first, right? And then put DP3. And if they are actual, then put it to DP1, right? But the previous one, if it is 3, 3, 3, 3, that means we should make sure that DP1 and DP2 they are both 0, right? And we put this one as a new DP1 as the counts, right? So we need a previous number as, let's say, the previous number, we can set this one as, because the range is to minus 1000, right? So we can set up, for example, minus 1001, right? Because at the index 0, we can always consider start as a new segment. So this is the same as it's not connect with the we can use put as 0, 2, right? So that it is between minus 1000 and 1002, there is one number, right? And you can also put, for example, integer minimum, right? You can put integer minimum. So we need to, let's see, iterate the numbers. And we'll have a count, right? We'll count current segment, the numbers. So the things that if this kind of I equals I minus 1 or nums I doesn't equal to nums I plus 1, right? Means we are at the end of current segment. So if at a current segment, what we need is that we already have this kind of segments that counts, right? So we'll say there are two kind of scenario. Is that first is that this kind of nums I equals p plus 1, right? So that means this is 5, right? This is 4. This current, this is 5. We count how many fives here. The previous is 5. Just the consecutive, right? So if nums equals pre plus 1, so we'll say there are then this is else, right? That means this is this segment, the new segment, they cannot add to the previous subsequences. For example, in the else, this pre, for example, is 4, current numbers is 5, right? This segment has 5, 5, 5, 5 here. But for this one, also the pre is 3, right? But this one has segment 5, 5, 5, 5, right? So means this 5 can be used in DP1 and DP2, right? So if there is DP1 and DP2, right, we'll say if the count is smaller than DP1 plus DP2, right? So we don't have enough um, nums I to add to the um, the subsequence which has end with pre and at length 1 and the subsequence end with pre and length 2. We don't have enough to complete, right? So we'll just return false. Else, else what we need is that we are have DP1, right? DP1 equals count minus DP1 plus DP2 plus DP3, right? That means uh, we want to put these numbers into DP1, DP2 first, and the rest we are going to put the DP3, but we don't have enough DP3. So the remainder will be a new DP1, right? And the DP2 will be DP1, right? Because we add one more number. And DP3 will be DP2, right? And plus the original DP3, right? DP3. But the thing is that for this count, it's possible this count this DP3 we didn't use all of them, right? So we can use the DP3 and count minus DP1 plus DP2, right? The thing is that these counts, right? It's possible this one there is no actual, right? So we are write max dot max 0, right? So if no actual, it's 0. And the thing is that this number changed, right? So we need some kind of variable, for example, uh, int new dp int new, right? Then set, for example, dp1 equals new dp1, right? dp2 equals new dp2, dp3 equals new dp3, right? And and yeah, we put this one, right? So if current counts in a pre, for example, they are not consecutive, right? So what we need is that we need to make sure that DP1 need to be 0. So that means this one is not 0 or DP2 is not 0, right? Then we return false. Then what we need is DP1, right? We should put this counts as DP1, right? Because they are new segments and cannot be used in any previous subsequences. And we'll have DP2 equals to 0, DP3 equals to 0, right? And so the thing is that because we finished this segment, we can clear those counts, right? Counts should be 0. And we can also set this kind of pre equals nums I so that we can be used in the next segment. In the end, what we need is just return dp1 equals 0, means there is no incomplete length 1 subsequences or dp2 equals 0, right? Let's take a look. If dp if I equals this is the end of our segment. So if this one is pre plus one means the current count segments they can be used in the dp1, dp2. So new will be minus dp2 will be dp1, dp2 mean dp3 count minus else if dp1 done equal to 0 or in the dp2 equals this is not all, should be n. Both should not be 0. Doing like this, the time complexity will be On and the space complexity will be constant. The Python code will be very similar. So we are going to have dp1, dp2, dp3, right? Means at the current segments, what is end with current segments, those kind of numbers, what is the sequence counts, which has length 1, has length 2, has length 3, right? And we can have n count 3, right? So n will be length norms, and the count should initially set as 0. This count is for this kind of segment. What is a count, right? And we can use a float minus IF, right? Or can use 1002, right? So for I in range n, what we need is that we should have count. We should keeping counting for this kind of segment. What is count, right? So if we are we are at the index, which is the end of this current segment. So if I equals n minus 1 or nums I plus 1 doesn't equal to nums, right? Then we'll have two scenarios. One is that for current segment, um, it is consecutive with those numbers is consecutive with the previous segment number, right? So that means for current segment, those kind of some number can be added to dp1 to get it as dp2. So, some of the number can be added to dp2 to get it as dp3, right? So I say if count is smaller than dp1 plus dp2, we'll just return false. Else, we'll have ndp1 equals max, right? Max 0, count minus dp1 plus dp2 plus dp3, right? So that means if for this current segment, if we add all of that to dp1, dp2, dp3, if there are still some remainder, we'll use as a new subsequences. And mdp2 equals dp1, right? Because we add 1, right? And ndp3 will be dp2 plus mean dp3, right? So that means um yeah, those kind of dp2, right? We should always put as um ndp3 count mean dp3 and count minus dp1 plus dp2, right? dp3 dp. So that means there is some coming from dp2, right? And the thing that for this counts, right? It is possible this one. Mm, actually, in dp3, actually we can put that as dp2 plus dp3, right? Because the thing that this one not can change the dp3's number. dp2. Yeah, let's look at this, right? So I have dp1, dp2, dp3 equals ndp1, ndp2, ndp3, right? And this is consecutive. Then else, right? If dp1 down equal to 0 or dp2 down equal to 0, right? Just return false because we need a new subsequences. And dp1, dp2, dp3 equals count 0, 0, right? And when we after this else, right? So we'll say we'll have pre equals nums, right? And we're going to have a count equals to 0. So in the end, we need to make sure there is no incomplete dp1, right? P1 equals to 0 and the dp2 equals to 0. Choose. Mm, Um, the things that this is wrong, right? Should still be mean dp3 count minus dp1 plus dp2, right? Because this one is a new segment dp3, right? So that means this dp2 will add one to this will be those kind of files dp3, right? Not will add, for example, those kind of so the dp2 one, right? 3, 3, 4, 4. Those kind of will be as the new dp3, but how many left, right? So that means we can only those kind of we end with a 5, right? So that means there is some kind of being used, right? So it will be count minus dp1 plus dp2. So let's try to see. Yeah, that so this is the ON and constant space um approach.